To all. Today class is chemical kinetics. My name is santhiya Priya, Assistant Professor of Chemistry, JJ College of Arts and Science, Pudukkottai. What is kinetics? Kinetics means studies the rate at which a chemical process. Kinetics is a chemical process. Besides the information about the speed at which reaction occurs, kinetics also sheds light on the reaction mechanisms. Outlines of the kinetics, it will be the reaction rates, how we measure rates, rate law, how the rate depends on amounts of reactant, integrated rate law, how to calculate amount left or time to reach a given amount, half life, how long it takes to react 50 percentage of reactants. Again yes equations, it will be the how rate constant changes with temperatures. Another then mechanisms, link between rate and molecular scale processes. Then factor that affect the rate reactions. First one, it's a concentration of reactants. As the concentration of reactant increases, so does the likelihood that reactant molecules will collide. Another than the temperature, at higher temperatures reactant molecules have more kinetic energy, move faster and collide more often and then the greater energy. Another than is catalyst, speed reactions by changing the mechanisms. So examples for speed reactions by changing these mechanisms. Another than reaction rate. Next one is the reaction rate. Reactions move on this pictures. Rate of reaction can be determined by monitoring the change in concentration of either reactant or product as a function of time. The formula for this delta concentration A versus delta T. The pictures, it will be the first one is 1 and A 0 mole B 0.46 mole B first, another 10 0.30 and A 0.7070 mole B. So three example for this reactions moves. Reaction rate, C4H9Cl is the aqueous plus H2O water is added will be the equilibrium reactions to give the C4H9OH plus HCl, then the hydrochloric acid. In this reaction, the concentration of butyl chloride C4H9Cl was measured as various time t. Next, the reaction rate C4H9Cl plus H2O to give the hydrochloric acid. The average rate of the reaction across each interval is the change in concentrations divided by the change in time. The average rate is equal to delta concentration C4H9 by delta T. Average rate delta C4H9 concentration by delta T is equal to 0.1000 minus 0.0905 mole by 50.0 seconds. Next then the C4H9Cl, the butyl chloride is added the water to give the hydrochloric acid. Then note the average rate decreases the reactions product. To give this picture, the average rate decrease the reactions. This is because the reactions goes forward there where a favor collisions between the reactant molecules. Next in the plot of the concentration versus time. The plot versus time versus concentrations yield the curve like delta concentration A by delta T is equal to D delta concentration A by D delta T. To, to curve this reactions, the plot, the slope of a line is drawn to the curve at any point as the intensity rate at the time. Then reactions is delta A delta T is equal to D delta A by delta T is will be the to concentration A, the reaction slows down with the time because the concentration of this reactant decrease. In this reactions, the ratio C4H9 is butyl chloride to give this butyl dioxide. Thus, the rate of disappearance of butyl chloride same as the reactant's appearance for the oxide C4H9OH. The reactions, the if the ratio is not. First question is what if the ratio is not 1 is to 1. H2 plus I2 is equal to 2HI. The rate reactions of formula delta concentration H2 by delta T is equal to half delta HI by delta T. So only half I is made for each H2 used. And the generalized for this reactions for stereochemistry, AA by BB is equal to CC by DD. Rate is equal to 1 by A by delta D, 1 by B delta B by delta D, and 1 by C delta C by delta D, 1 by D delta D by delta D. The reactant decrease, product it will be increase. The concentration and rate, each reaction has its own equation that gives its rate as a function of reactant concentration. This is called rate law. What is rate law? What is mean by rate law? It will be the determine the rate law will measure the rate at different starting functions, reactant concentrations. Concentration and reactant is NH4 ammonia is NO2, Q is N2 plus 2H2O. Compare the experience of the reactions when NH4 doubles the initial rates doubles. So, likewise, compare experiments of 5 and 6 when NO2 doubles the initial rate doubles. The concentration and rate directly proportional NH4, directly proportional NO2, directly by NH4, NO2, K, NH4, NO2 concentrations. This equation is called rate law. K is the rate constant. For example, NH4, NO2. The rate law, it will be D, shows the relationship between the reaction rate, the concentration of the reactant. The gas phase reactants is pressure P, instead the concentration K is constant. Specific value for each reaction. So K is the constant value for each reaction. The value K is determined experimentally. The constant is relative here. The K is unique for this each reactions. The changes in temperature, the rate law, the component and the order of the reactions with respect to each reactant. This reactions is first order in NH4, first order NO2. The overall reactions are order can be found by the adding the exponents on the reactant in the rate law. The reactions is second order overall. Rate equation, rate is equal to K NH4 the concentrations are inverse concentration NO2. Integrated rate law. We considered a simple first order reactions, it will be the A equilibrium B. Rate is equal to K concentration B. Differential form. Then another than integrated law. Integrated form, the first order rate law. Concentration AT is equal to concentration A E minus KT. Another than the ln concentration A is equal to minus Kt. Concentration A is 0 is the initial concentration. A is equal to T is the concentration of A at this time T during the course of this reaction. So the integrated law, multiplicating the equations, it will be these equations. Another then first order process. In ln A, the reactions first order plot ln A versus T, it will be temperature. We yield the straight line of the slope of the K. We use graph determine these reactions. First order process CH3NCQ, CH3CN. The methyl isonitrile is converted to acetonitrile. How to know this first order reactions? It will be the methyl isonitrile. It will be converted to acetonitrile. The another than the this data was collected this reaction 198.9 degrees Celsius. Then the time travels it will be noted then slope. Next thing this slope it will be difference than this reactions. The P is plotted the function of T, the straight line result. The process is first order. K is the negative slope 5.1 into 10 power minus 5 second minus 1. The second order process, similarly integrating the rate law for this process, second order reactant A. Then rearrange integrate of this reaction. So form Y is equal to mx plus b. Second order reactions, it will be process the slope A, plot 1 by A versus the T. The slope, it concentrated A, the first order reaction, it will be the straight line, the slope of this minus K. Then slow, the decomposition of these reactions, it will be the NO2 at 300 degrees Celsius is it will be heated to give the NO plus of H2 yield of this data. The time NO2 mole as 0.0, 0.01000, 50.0, 0.007867. If another than this, another examples will be the needed. Determine the reaction order graphing in wood versus tea yield. Then another thing, the plot is not a straight line. The process is not a first order reactions. The second order, the straight line, the process is the second order. It will be straight line is second order. If not will be straight line is not the first order reaction. The half-life period is defined as the time recovered one half of the reactant to reactant. Because concentration A and time T, one half of the original reactions. The zero point 0.5 concentration, the initial stage. First order process, it will be the half-life ln zero point 0.5 concentrated A initial stage minus KT 1 by 2 to give this reaction 0.693 by K is equal to T half. This is the half-life of the period time. Is note the first order process half-life is not dependent on this concentrated A initial. The second order reactions 1 by K concentrated A is equal to 1 by 1 by 2. D by 1 by 2. This difference will be the kinetics reactions. Second order reactions will be the needed. The first rate law, integrated law, half-life periods, it will be different needed to this kinetics. Then another than the temperature and rate. Generally as temperature reactions does the reaction rate is because K is the temperature dependent. The collision model, the chemical reaction bonds are broken, new bonds are formed, molecules can only react if they collide with other. Then collision model, it will be collision model, they collide with correct orientation with the young energy, the bond breakage of the formation, the before collision, second collision is after collision. So, next one, activation energy. The another words, the minimum amount of energy required for reaction is activation energy. What is activation energy? It will be the show the then minimum amount of energy required for those reactions. The reaction coordinate diagrams. Next one, the reaction coordinate diagram for this reaction. The transition activated complex for this reaction. Then another one related to Maxwell-Boltzmann distributions. Then Maxwell-Boltzmann distributions as dotted lines, it will be graphs, Boltzmann distributions of formulas, the Arrhenius equations. What is Arrhenius equations formula? K is equal to A minus A by RT frequency factors. It will be taken the equations, then graph plotted, the outline for this reactions, reaction mechanisms, the elementary reactions, multi-step mechanisms, and then slow initial step, final steps reactions, NO2, NO2 plus NO3 reactions, the fast initial step reactions. Mm, Another than other examples. Um, so reactions rate, overall reactions, final stage reactions. um, Another than the rate law of these reactions. Next one very important for these reactions, the catalysis. Catalyst increase the rate of the reaction by decreasing the activation of these reactions. Change in mechanism for these reactions. Overall the catalyst enzymes. The enzymes are catalyst in biological systems. The substance into active site, the enzymes much like the key for these reactions. So enzymes, it will be enzyme substrate complex, it will be this enzyme. This is called this enzyme. Thank you.